A very good afternoon to Dr. Shakaf. My name is DINESH Kumar A and my metric card number is 251062034. Today I'm going to present about my project in Cisco Packet Tracer. My project name is Smart Autonomous Logistics System for Warehouse with Security. The objective of this project was to design a network that supports a modern automated warehouse. The system needs to support three distinct groups: the automated robots and workers on the floor, the supervisors in the office, and the core server infrastructure. To achieve this, I have segmented the network into three functional subnets. First, on the left, we have the production area. This is assigned the 192.168.10.0 network. This is where the warehouse workers and stock keeping robots operate. Crucially, this is also where I have placed the security camera physically located on the warehouse floor. On the right, we have the administration area. This is assigned the 192.168.20.0 network. This is for the supervisors who need to monitor the operations remotely. And at the top, we have the server farm. This is the 192.168.30.0 network hosting our critical services. Let's look at the hardware. In the center, I am using a 3650 multi-layer switch as the core. I chose this because it handles the heavy traffic between the distribution switches. Connected to the core is the 2911 gateway router. This device is the most important piece for our service security logic. It performs inter-VLAN routing, allowing the admins on the 20 subnet to talk to the camera on the 10 subnet while keeping the broadcast traffic separate. You will also notice wireless access points on the both production and admin sites. In a logistics environment, mobility is key. Supervisors need to walk around with the laptops, and autonomous robots often rely on Wi-Fi, so wired connections alone were not sufficient. Now I want to highlight the automation features of this network. In a real warehouse with hundreds of devices, static IP addressing is impossible to manage. I have configured DHCP dynamic host configuration protocol on the main server. As you can see, I have created distinct pools, one for production 10 addresses, one for admin 20 addresses. However, since the server is on subnet 30 and the clients are on 10 and 20, they are physically separated. To solve this, I configured the IP helper address command on the router interfaces. This forwards the DHCP requests from the workers directly to the server, allowing for seamless automation. Let's demonstrate this live. I am resetting the worker's PC. Now watch what happens when I request an IP. The server replies and there it is. DHCP request successful. The PC has automatically received an IP in the 10 days along with the correct gateway and DNS server. Now for the operational workflow. I am currently logged in as a supervisor on laptop 1. I need to check the inventory system. For now, I navigate to www.warehouse.local. So we utilize a DNS server, so staff don't have to memorize the IP addresses. So the site loads successfully. Okay. In this inventory system, this is where the workers can log the necessary stock information on products, and the higher ups can monitor them if they need to place orders and such. So the next is below is the security footage, where only those who have the access can view it. If I use the wrong passcode, it denies entry. Let me show you. So as you can see, it shows access denied. So if I use the correct passcode means we can enter to the security camera. The camera is located on the production floor. Now I'll open the IoT monitor to show the cameras. Okay, as you can see in front, the IoT server address showing 192.168.25.1, but if I change only, I can enter to the 30.10. So if I log in means I can enter to the IoT monitor. So as you can see over here, I can check the camera. So the camera is operating successfully. This proves that our inter-VLAN routing is working. The supervisor can securely access the camera feed across the network boundary without the workers on the production side having the direct access to the admin network. So now let me show you the simulation. Okay, to conclude, this project successfully demonstrates a smart logistics network. We have achieved physical and logical segmentation using the subnets. We have implemented full automation using DHCP and helper addresses, and we have ensured operational security by restricting traffic while allowing necessary access to the security camera. So this design ensures the warehouse runs efficiently, securely, and is ready for the future expansion. That's all from me. Thank you so much.